Hello, my name is Amay Gowde and I'm going to explain you about multi-output classifier. So consider we have a data set related to energy efficiency where some of the input features related to a building will give you output feature related to heating load. So consider you have a X1 feature which is wall area, X2 feature which is roof area, X3 feature which is surface area. And last, you have a orientation of this building related to east, west, or south. So based on this input feature, you got one output feature, which is heating load, which means a total energy required to heat that particular building. But this one is pretty easy, but life is not that easy. And based on the same features which you considered as input feature, you can have two output feature, which is heating load and cooling load. As name suggests, heating load is for the energy required to heat the building, and cooling load is energy required to cool the building. So now, if I have to classify this data into two output features, we will call it as multi-output classifiers. But to do that, first you will do the explode data loading in step one. In step two, you will do EDA, and from step three to till step six, you will do a data pre-processing, meta model declaration, hyperparameter testing, and model optimization for Y1. And again, you will repeat this step three to step six for the Y2 Y2 output. In a way, this process is quite repetitive. To summarize, I will say first you will give input and from x1 till xn factors, and then you will get an output of y1. Then again you will give that same input back to the processor, and it will give you uh, the output that is y2. But in an ideal situation, we want a process where we just have to give an input once and we will get output twice. For to do this, to particularly to do this, we have something called multi-output classifier, and I will explain it in a better way with the code. So consider I have a Titanic database and I'm going to predict a, a survival rate and passengers class based on the gender, age, and fare. So first we will load the data, then we will not do any data cleaning. We will directly drop all the NA values. Then in data pre-processing, we will let me just go up. We will put two variables as our output variable. As I said told you earlier, we will check first predict the survival rate, and also we will do a passenger class classification. For as a x variable, as input variable, I have given a variable of gender, age, and fare. So based on our gender, age, and fare, we will predict survival and passenger class. Now, if you see our x variable, which is input, has three columns, and our y, which is our output, has a two columns. So one column is for the survival, where you can see survival has two like 2 feet particular values in it. Zero, which is not survived, and p class, where the passenger class has three values. Then we will move down to the most important point, which is multi output classifier. So by using a multi output classifier, I'm giving this value once to the model, and model will just check the both of the values will arrange accordingly and will give me an output in a 2D array. So the first column of the array is first value of the array is basically related to survival, and the second value is related to the passenger class. Now, in terms of the model prediction, you can check all the prediction values or the prediction you can say extensions as same as the normal model classification. So you can do a predict proba. Apart from that, there is a specific extension which you can use, which is classification estimators, which will tell you which model we have used in classification. You can use multiple models and check their and you can use different models also. Then we can get parameters. We can check the evaluation model evaluation by doing the classification report and accuracy report, and it will give you a specific classification and accuracy report based on the classification which you want. So for my survival classification, it is giving me accuracy of 78%, and for my passenger class, it is giving me good accuracy of 91%. So what we have achieved by doing the multi-class classification or multi-output classifier, we have just reduced the number of workflow from a huge again and again data pre-processing, data classification to just 10 steps. In a way, this will reduce your total workflow in terms of meta models. It will not reduce your workflow in terms of deployment. Why? I will explain you in next slides. So as we know, why should we use multi-output classifier? First one, it can handle multiple outputs. Most of the machine learning model are designed for single output classification, where you can only give one output or one test data, one array test data. Thus, we need a wrapper like output classifier. This sentence is it's important. Multi-output classifier is not a tool; it's just a wrapper. So, which means particularly it will enhance the or it is like shortcut to do the meta model testing. Again, the second major advantage is individual model for each target. So, rather, even though we are sending out input variable once, it will create a separate model, which we have already seen in terms of the parameters, where it was mentioning two different models. Then, as you can see, by just doing this multi-output classifier, it is a single window to do a fit and predict methods on to train and predict the multiple outputs. Now, let's just talk about why we can't use multi output classifier in production. The major uh, disadvantage about multi output classifier is in terms of production is performance and scalability. So even though we are giving the input once, but each classifier will run independently, and it will in a way for like we just checked for the small database which was Titanic database. Consider a huge production database. For that, it will be a computational overhead for training and for prediction. Then again, as you have a different classifier models, you will have a huge number of memory footprint, which is larger, potentially becoming a limitation for system and restricting all the memory capabilities. In terms of it will just like managing and monitoring the multiple models and also doing a like doing a hyper parameter testing will be a difficult task for by using the multi-classifier production. Um, I can I can simplify this more by giving you an example. Like, consider you have a dog, and there is a huge stack of like mixed stack of balls and sticks. So your this consider this dog as your multi output classifier. He will go and he will check your input, which is the stack, and he will give you a classification of a stick once. Then again he will go to your input and he will do a classification related to a ball. This process will be repeated again and again and again. So now, rather than one dog or one model, consider you have two dogs, which means two models. And then you give them a specific task. For dog one, you tell him, first you have to go to the stack and only get stick. For dog two, you have to get a ball. Then they go to the input out variable, which is same, but they will specifically select their own outputs and will give you result. So as you can see, the second approach is more simple, more faster. Thus, in production, it is highly recommended that you should have a different models for doing multi-output classifier from the same input, which in a way simplify your total deployment process and also your memory usage. In the whole um, in the whole situation, like in the whole video, we talked only about classifier, but the same tool can be also used as a regression. So with the same input, you can also do a regression task to predict how much heating is required and how much cooling is required based on the input variable. So I hope I have explained you in terms of what is multiple output classifier. And if you have any doubt, please do share with me.